Hello guys, so from this video I'm going to start with a new series on computer vision. So we are going to see different things in this series. So let's start with the first video. So here I'm going to cover some of the image transforms. So one of them is rotation. So what happens in rotation is, suppose I'm given with an image, say this is a object, this is the image, and now my objective is to rotate this image. So I will rotate this image like this. So I need some sort of function or something that will help me to rotate this image like this. So my original image was, say, over here, and I have rotated this image like this. So this is my task that I want to do. So let us see how can we find that function or that mapping that tells me that if I have this as an input image, so when I put that into that function, I get this particular output, this rotated output. That is what I want to do. So let us see what we can do. So consider that this input image has coordinates x comma y. So any point, say this point, this point, this point, any point in this image can be denoted by xy, and the coordinates in this image are x dash y dash. So the output image has coordinates x dash y dash. So now what is our motive is to rotate all the points in x comma y such that they become x dash comma y dash. So let us start like this. Say over here, this particular point, say on this pencil, this particular point is nothing but my x comma y, because this pencil is nothing but my original image. So since this is my original image, this is nothing but my x comma y, and this output that I want, this pen, this blue pen, this will be my corresponding x dash comma y dash. So what is my motive is, if I get a input that is this x comma y, say if you can put them in numbers, so say this particular point, say this point over here is some coordinate, say say 2 comma 2. So say this is 2 comma 2. So this thing over here will be 2 comma 2, because this and this is the same, it is the same image. I have just overlapped both of them in the on one another. So this is 2 comma 2, and say this point, this, when this is rotated, so this 2 comma 2 got shifted to some point, say 1.5 comma something, will be say 2.5. So this 2 comma 2 got shifted to 1.5 comma 2.5. So you can see that it has rotated. Similarly, this point over here, this point, say this point is it is x coordinate 2 and y coordinate say 1, and this got shifted to this point. You can see that this shifted to this point. So for this is x comma y, and this is corresponding x dash comma y dash. So you can see that every point, every x comma y over here is getting shifted to some x dash comma y dash. So there is some correspondence. So every x comma y will have some corresponding x dash comma y dash, and this mapping is what we have to discover. Okay, so let us see how can we do this. So what am I doing is, consider any one point, say I am considering this point, and I am drawing a vector over here. So this is my origin, say this center of the image is my origin, and I am just drawing a line from the origin to this x comma y, this 2 comma 2, right? Also I am drawing a line from this to this x dash comma y dash. So what I essentially mean is that this x comma y has to be transformed or changed to x dash comma y dash. That is my objective. So let me zoom this whole operation over here, right? So I have this x comma y over here, which is nothing but this line, and I have this x dash comma y dash over here, which is nothing but this line. Also please note that in rotation, the distance from the center to this point, this will not change because I've just rotated it. I have not squashed it or something else. So let this distance be r, which is what I have denoted over here, and similarly this is also r because the distance does not change from the center, right? So this is what we have. So now if I do simple geometry, so this point, this over here becomes r cos alpha, because this is r and cos alpha, and but you can see that this is nothing but x. The x coordinate of this line is nothing but r cos alpha, right? So that is what I have written over here. X is equal to r cos alpha. On similar terms, you can get if you see over here, so this is y, this particular thing is y, and this is r sin alpha. So similarly y becomes r sin alpha. Okay, now if you take this particular thing, this, so this is x dash, let me write it down. So this is x dash. So x dash is nothing but r cos alpha plus theta. So it will be in the addition of both, r cos alpha plus theta. So that is what I have over here. X dash is r cos alpha plus theta, and similarly I have y dash, which is r sin theta plus alpha, r sin alpha plus theta, or theta plus alpha, whatever. So that is what I have over here. So now it is simple trigonometry. I just open these things. So what I get is x dash from here is r, so cos a plus b is cos a cos b minus sin a sin b. So that is what I have used over here. And similarly y dash is nothing but r sin a cos b plus cos a sin b. So this is basic trigonometry. And now what I do is, you can multiply the r inside. So here you can see there is a r cos alpha term over here. So this r cos alpha will make it x, and now when you multiply this over here, so that you will get an r over here. So this r sin alpha becomes y. Similarly in y dash, r sin alpha becomes x, and r cos alpha becomes y. Oh sorry, r sin alpha becomes y. So I have written it over here because I wanted the y terms below each other, and r cos alpha becomes x, which I have written over here. So that's what. So now this is what we call as a linear equation, because you can see that the powers of x and y are simply 1. So for a linear equation, you might have known this term. So this is what we actually denote linear equation with. Y is equal to mx plus c, or sometimes it is ax1 plus bx2, so ax plus by is equal to c, some sort of like these equations we know. So here you can see the degree of both the variables. So here x and y is a variable, so the degree of both the variables are 1. Because of this, they are known as linear equations, because they have degree 1. Very similarly, here you can see x and y are my variable. Why x and y are variable? Because I can choose any point on this particular plane or this image. Any point on this image, say specific case this 2.2. So I could also have this what is this 2 comma 1. I could also have this, I could also have this. So this is a variable. So x and y is a variable, and that is what we say of a degree 1. So because of this, this is called a linear equation. And now you can see that I can put this or form this like a matrix vector notation. So what I've done is just taken this x and y as a vector, and I have put these particular weights as a matrix, weight matrix. So you can see that if suppose I multiply both of these, I get these equations back. So I have x cos minus y sine that is equals to x dash, and similarly x sine plus y cos, this is equal to y dash. So this particular operation that I have done, so I have inputted a vector xy which is nothing but my original image, and I've got an output x dash y dash that becomes my output image. So just by multiplying my given vector xy with this matrix, I can get my output. So now you will have a question, what is theta? So you can see that theta is nothing but the angle between them. So when somebody says rotate it, so you will always ask that how much should I rotate? Should I rotate it 1 degree, 2 degree, 3 degree, 90 degrees, perpendicular 90 degrees, or what? So that is what is theta. So for a particular transform, this theta will be constant, because say over here, so say this is 30 degrees. So now this is constant, this to this 30 degrees. So cos 30 sine 30 sine 30 cos 30, like that, right? So this is what we have over here. Next, so on the similar basis, we'll see what is scaling. So this is quite easy. So in scaling, what we do is we just it is like a sort of zooming. So we have increased the size of the input. So this is my input image and this is my output image in scaling. So say if this was 2 comma 2, so now say this becomes say 4 comma let me use say 4 comma 6. So this is what it has become. So this was 2 comma 2, this become 4 comma 6. See, this is 2 comma 1, so this has become say 4 comma 3. So it has scaled. So now I'll tell you why these numbers are like this. So over here, say, so this output image becomes my x dash comma y dash. So all the pixels or all the locations over here are denoted by x dash y dash. So x dash becomes a times x. So a is some constant. So here you can see I have just zoomed it sort of. So initially my x was 2, now my x becomes 4. Initially it was 2, it became 4. So what I have done is over here in this particular mapping, I have set a is equal to 2. So x dash is nothing but 2 times x. That is in this particular term. So like this, in general you can have any ax. Similarly for y dash. So for y dash, what I have done is I have scaled y dash by 3 times. So you can see when it was 2, it became 6. 2 into 3, 6. And it was 1, it became 3. So here I have taken b as 3. So you could have equal values, you can scale it any ways you want, right? So that is what I have done over here. So similarly here also you can see that these are linears, because there is only a degree 1. So I can transform this into a matrix vector notation. So this is what is I have, and by this particular transform, so these are known as transformations, image transforms. Why transformations? Because I am going from one particular plane, so this is my input plane or image plane or whatever you can call this, to a different plane which is having some properties, like this is rotating the plane and this is scaling the plane. So now let us go to Desmos, and I will actually show you how the planes are rotated. So this is like a still sort of thing, that will be a good animation sort of thing. So let us go to Desmos and explore. We are in Desmos. So just you can type 2D transform Desmos, so you will get this. Also I will provide the link in the description below for this website, so you can play with it as you want. So this particular thing is inspired from a three blue one brown video, or a series, that is vectors or linear algebra series. So it is a very beautiful series. I recommend you to watch the series. It is quite intuitive and very nice series. So coming back over here, so this is what is my input plane. So this is my image plane, what I'm seeing over here. So now, if suppose I am given a matrix, say this is my matrix. Okay, let me do this over here. Yeah. So suppose this is my matrix. So we saw in rotation, what we do is we have over here we have cos theta. So say let me have cos A over here. So I have cos A, I have sin A, and so this is a minus sin A. Yeah. So this is minus sin A. This is sin A, and this is cos A. Right. So also I'll have to put A value. So let A is equal to say 45. Okay. So I've got things done. Now let me see whether it is in radians mode or it is. So this is in radians mode, so you can change this to degree mode. Okay, so because I am using degrees, so you can change this from setting over here to degrees mode. And yeah, so also you can define a range for this. Say the range is minus 90 to plus 90, suppose. So I've defined a range for A, and now I can change the values of A as in I want. Okay. So say I've kept this at 45. So now, yeah, 45. And now you can see this is my given image plane. Now let us see what happens when I transform it to the output plane. So this is my image plane. So you can see it will become like this after I have transformed it. So when A is equal to 45, I get this as my output. So you can see that these lines were over here, but now they have rotated like this. So you can see the rotation. So this was my image plane. Now I have got this particular thing. So you can see that it has rotated. So this was my center point, the origin of the image, and it was like this, the image. This was my image plane. So as I put this particular matrix over here and I set A is equal to 45, I can, so this is what happens. This becomes my output. So this, you can see that there is 45-degree line over here. Now similarly, if you change A, so this was 45 degrees. If I make this 90 degrees, so you can see that it has turned 90 degrees. So please don't get confused between these two knobs. This is like A animate. So it is giving this animation from this input. This A is equal to 0 means your input plane, no transformation applied. And A animate is equal to 1 makes it full transformation applied. So this whole matrix has been applied over here. And this is my actual angle. So this A is nothing but this cos A that I have written over here. So you can see different degrees. When so I can go minus, and then this is nothing but minus 90. So this is what is linear transforms is all about. So this is the rotation. Similarly, you can have what we say scaling over here. So say I have 2 and I have say 3 over here, and I make this as 0, and I make this also as 0. So here you can see that this is scaling. So when this was 0, so this was my image plane. Now you can see that when I'm increasing it, so it has zoomed. So it was this was my image. Now my image has zoomed, and you can see it is uh, three times in the y direction and two times in the x direction. So suppose if I make this 4, so you can see this increased. So it is like squishing it in the y plane. Uh, Sorry, stretching it in the y plane. Sorry. And similarly, I could make this say 1. So this is squishing it in the x plane. So like this, you can try different values over here and enjoy. Thank you so much for watching. Thank you.